Finding life beyond the borders of our own planet remains the dream of every astronomer on the ball of rock we call our home, and the focus of dedicated missions ever since humanity ventured into space a few decades ago. Yet, despite our best efforts, no definitive proof has been found yet that life exists out there, in whatever form. We keep seeing traces, hints, and clues that life either existed or is still present both inside our solar system and beyond. To date, we still haven't confirmed that to be so, let alone for us to find signs of an alien civilization. Imagine my surprise, then, when earlier this week social media went ablaze with info that we finally got it. But did we, really? Sure, the findings are pretty encouraging, but they don't go beyond being traces, hints, and clues, just like all others before them. Granted, we're talking about the strongest hints yet of biological activity, or most promising signs yet of a possible biosignature outside the solar system, but that's still far from being proof of life. Here's the whole story. The news came our way thanks to a team of astronomers led by the University of Cambridge. These guys published a paper in the astrophysical journal Letters, detailing observations made with the help of the James Webb Space Telescope on a planet called K2-18b. It's a name you might have heard before, as this is not the first time it's a prime suspect for harboring life. K2-18b is a monster of a planet. Located in the constellation Leo, at a distance of 124 light-years from Earth, it is 8.6 times more massive and 2.6 times larger than Earth. Yet, it resides in its solar system's habitable zone, meaning a place that's both close and far enough from the local star for water to exist in liquid form. Back in 2023, the same Webb telescope was responsible for detecting, for the first time in the history of space exploration, carbon-based molecules methane and carbon dioxide in the atmosphere of the planet. And now, K2-18b is in the news once more, this time thanks to the discovery of hints that the atmosphere may contain stuff called dimethyl sulfide or DMS and dimethyl disulfide or DMDS. These are substances that here on Earth are the result of life activity, more specifically that of marine phytoplankton. In the atmosphere of Earth, DMS and DMDS can be found in a concentration of under 1 part per billion by volume, but the Webb observations of the alien world point to its atmosphere holding a concentration of over 10 parts per million, thousands of times more than back home. It's unclear why that's so at this point, and the methods used to detect them are not enough to give us an answer that could shine light on this difference. Just like they do with every other planet they study, astronomers looked at K2-18b's parent star as the planet was passing in front of it, and then analyzed the stellar spectrum resulting from sunlight passing through the planet's atmosphere. A cool way of learning what kind of gases are present in an alien atmosphere, but not nearly enough to answer more questions. The two molecules are definitely there, though, as they've been confirmed by 3 of the Space Telescope's instruments, namely the near-infrared imager and slitless spectrograph, the near-infrared spectrograph, and the mid-infrared instrument. Because the two molecules have overlapping spectral features when observed this way, the team behind the discovery is unable to say what the ratio between DMS and DMDS is. It also says that to definitely confirm the fact that the two are the result of life activity, and not some other, unknown chemical process, it would require an extra 16 and 24 hours of follow-up observation with the Webb. In the scientific world, for something to be considered a discovery, the so-called 5 sigma threshold must be reached, which means that the finding, whatever it is, has only a 0.00006% probability of having occurred by chance. The K2-18b molecules are presently at 3 sigma, meaning there's a 0.3% chance they occurred by chance. It's unclear if and when the team will get more access to Webb data from this planet, or new data altogether, in a bid to confirm their findings. Although the team remains cautious about the findings, there is enough proof for astronomers to hope that K2-18b, presumably an ocean-covered world sitting under a hydrogen-rich atmosphere, may be teeming with life. We'll anxiously wait for more Webb observations of this world, but the chances of us getting real proof of life outside the solar system will grow exponentially when the dedicated telescopes from the Habitable Worlds Observatory program get going sometime in the coming 2 decades. There is no question about it that K2-18b will be one of the targets of these new telescopes, now that the Webb designated it as a potential home for alien life.